light, reflection and refraction. One ray is passing what from the object, it falls at this place and it gets reflected back. Why? Because it passes through what? Center of curvature. See, I am understanding that image is formed at this side at a distance of what? At a distance of 30 centimeter. So focal length is what? Plus 15 because the measurement is taken to the right side. This is first medium, this is second medium. So which medium lighter have reached? Second medium. From which medium it has started? First medium. That is equal to what? V1 by V2. So hello students, we are starting new chapter, light, reflection and refraction. Key concepts. Introduction to light. Light enables us to see objects by reflecting off them and entering our eyes. If you are seeing a leaf with green color, you should understand that leaf absorbs all the color and reflects only green color. If you are seeing a flower with red color, you should understand that flower absorbs all the colors but reflects only what? Red color. So what are the different colors? Vibgyor. So Vibgyor stands for violet, indigo, blue, green, yellow, orange, red. Okay, light enables us to see objects by reflecting off them and entering our eyes. Light appears to travel in a straight line. Very important point. Light reflects off from objects. Light travels in straight line. A small source of light casts sharp shadows indicating straight line propagation. See, a small source of light casts what? Sharp shadow. What does it indicate? Light flows in straight line. However, light can bend around very small objects. This bending of light ray around obstacles of very small size is called diffraction. Now, what is speed of light? What is speed of light? Speed of light is equal to 3 into 10 to the power 8 meter per second. What is speed of light? 3 into 10 to the power 8 meter per second. Speed of light in air or vacuum. Okay. So we will move to the next slide. Laws of reflection. The angle of incidence equals angle of reflection. See, suppose this is a reflecting surface and this is normal. This is the incident ray. So what is the angle between incident and ray and normal? Angle of incidence. This is the reflected ray. What is the angle between reflected ray and normal? Angle R. Angle I is what? Angle of incidence. What is angle R here? Angle of reflection. Angle of reflection. So what you are understanding from this line? Angle of incidence equals angle of reflection. That means what? Angle I should be equal to angle R. Now, I have drawn incident ray, reflected ray. This is normal. This dotted line is what? Normal. It is perpendicular to the surface. So, incident ray, reflected ray and normal. All rays I have drawn on the board. No rays penetrating into the board or coming out of the board. That means what? Incident ray, reflected ray, normal. Everything is on the same plane, which is our board. So what are the two rules? Incident angle should be equal to reflecting angle. Then incident ray, reflected ray and normal all should lie on the same plane. Now, what is an incident ray? What is incident ray? Angle incident ray. This is incident ray. This is what? Reflected ray. Reflected ray. So what is angle of incidence? It is the angle between incident ray and the normal. What is angle of reflection? Angle between reflected ray and the normal. The red dotted line is normal. This is what? Normal. So that is the law of reflection. These laws apply to all reflecting surfaces including spherical mirrors. Okay. Now, images formed by plane mirrors are virtual and erect. These are the different types of images formed by plane mirrors. What are they? Virtual and erect. Erect means straight. Same size as of the object. Laterally inverted means ulta. Then as far behind the mirror as the object is in front. So object distance and image distance both will be same. These are the different types of plane mirror reflection. Then spherical mirrors are of two types. First one is concave mirror and the other one is what? Convex mirror. If reflection takes place from inner side, what is specialty of concave mirror? Reflection takes place from inner side. From inner side. What happens in convex mirror? Reflection takes place from the outer side. Reflection takes place from the outer side. From the outer side. Schematic representation of spherical mirrors, the shaded side is non-reflecting. So, if this is this a concave mirror? That you can't say. If you are shading outer surface, now it becomes what? Concave mirror. Now, if you are giving shading to the inner side, then it becomes what? This is concave and this is convex. Types: concave mirror, reflecting surface curved inward. Convex mirror means what? Curved outward. Important terms. Now listen, students, you should understand that there was a spherical mirror. Okay, there was a spherical mirror and we are cutting a portion of the mirror. The dotted line is taken away. So only half section we are seeing. This is a concave mirror. How it becomes concave mirror? If you give a coating on the outer surface, now it becomes what? Concave mirror. Now, center of the sphere is what? Center of curvature. Center of the mirror is what? Pole. What is C? C stands for center of curvature. What is center of curvature? It is the center of the sphere of which mirror forms a part. What is center of curvature? It is the center of the sphere of which mirror forms a part. What is pole? Geometric center of the mirror. What is pole? Geometric center of the mirror. What is the center of curvature? Now, what is PC distance? PC distance equal to radius of curvature. What is PC distance? Radius of curvature. PC distance equal to radius of curvature. Now, remember, narrow parallel beam of light, parallel and close to principal axis, after reflection from the mirror, converges to a point on the principal axis. This point on the principal axis is called principal focus in the case of a concave mirror. See, what is principal axis? So obviously you should know what is the principal axis. A straight line which passes through pole and center of curvature is called principal axis. A straight line which passes through pole and center of curvature is called principal axis. See, narrow parallel beam of light, parallel and close to principal axis, after reflection from the mirror converges to a point on the principal axis, and this point is called principal focus F. This point is called principal focus F in the case of a concave mirror. So what mirror is this? Concave mirror. Now we can show you the same thing to convex mirror. So this is convex mirror. Now here pole will be here, this will be the center, this will be the pole. So this distance will be what? Radius of curvature. Now see, the straight line which passes through pole and center of curvature is what? Principal axis. Narrow parallel beam of light, parallel and close to principal axis, after reflection from the mirror converges to a point on the principal axis. This point on the principal axis is called principal focus in the case of a convex mirror. Again, principal focus in the case of a convex mirror. Now, I am moving C a little bit far away. Let this be C. This is the principal focus. See, in convex mirror, reflection takes place from the outer side of the mirror. So what happens? Narrow parallel beam of light, parallel close to principal axis, after reflection from the mirror, appears to diverge away from a point on the principal axis. Narrow parallel beam of light, parallel close to principal axis, appears to diverge away from a point on the principal axis. This point on the principal axis is called what? Principal focus in the case of a convex mirror. Now remember, distance between pole and principal focus is called focal length. Distance between pole and center of curvature is what? Radius of curvature. Now here also distance between pole and principal focus is what? Focal length. Distance between pole and center of curvature is what? Radius of curvature. Then we can prove that R equal to 2F. For a mirror, radius of curvature is what? Twice the focal length. Radius of curvature is what? Twice the focal length. Now let's see. Pole. Pole is what? Center of the reflecting surface. Center of curvature. Center of the sphere of which the mirror is a part. Radius of curvature is what? Radius of the sphere, or it is the distance between pole and center of curvature is the radius of curvature. This distance is radius of curvature. Principal axis, straight line passing through the pole and center of curvature. Principal focus, point on the principal axis where parallel rays converge in the case of concave or appears to diverge from in the case of a convex. What is focal length? We know that R equal to 2F. So F is equal to what? R by 2. So F is equal to what? R by 2. R equal to 2F. I hope it is clear. See, here object is at infinity. Light from the object after reflection from the mirror converges to a point on the principal axis. This point on the principal axis is what? Principal focus. The same thing happens in the next case. What happens there? Narrow parallel beam of light, parallel close to principal axis, after reflection from the mirror, appears to diverge away. See, when you look from this point, it appears to diverge away in the case of convex mirror. This narrow parallel beam of light, after reflection from the mirror, converges to a point on the principal axis in the case of a concave mirror. Concave mirror converges incident light convex mirror diverges incident light. Then image formation of a formation by concave mirror. See, here we are seeing multiple ray diagrams. Now you should understand each ray diagram. First ray diagram, ray parallel to principal axis. When the ray is parallel to principal axis, it reflects through the focus or appears to come from the focus in the case of convex, reflects through focus in the case of concave, or appears to come from the focus in the case of convex. In what case? When the ray is parallel to principal axis. Ray through the focus, then what? Reflects parallel to principal axis. If ray is through the focus, it reflects parallel to principal axis. Ray through the center of curvature reflects back along the same path, which is a very important. If the incident ray is through the center of curvature, it reflects back along the same path. Ray incident at the pole reflects making equal angle with the principal axis. So what are the points? If the ray is incident at pole, it will reflect making what? Equal angle with the principal axis. If ray through the center of curvature reflects back. If ray through the focus reflects what? Parallel to principal axis. Ray parallel to principal axis reflects through the focus either concave or appears to come from the focus if it is convex. Let's see these diagrams. See what you are seeing. Ray is what? Parallel to principal axis. So it goes through principal focus in the case of concave. This is concave. This one. Ray parallel to principal axis allowed through the principal focus. Then ray through the principal focus. What happens? It goes parallel to principal axis. So this is also concave. Now what happens in convex? Ray parallel to what? Principal axis. It appears to diverge away from a point. See, it appears to diverge away from focus. Again, what? Remember, angle of incidence is equal to angle of reflection. Why? Because it is reflection, which is reflection has to follow law of reflection. So here also angle of incidence is equal to angle of reflection. What is this dotted line? This dotted line is what? Normal. This one is normal. In all the figures, the middle dotted line is normal. Now what happens here? Again, a ray is parallel to principal axis. So what? It deviates through what? Away from principal focus. I hope it is clear. I hope it is clear. We have seen whatever which is written here, we are proving with the diagram. Then a ray passing through the center of curvature, what happens? It gets reflected back. In the concave, this is concave, the same thing happens through convex. Okay. So you have to study this, you have to draw this. Then a ray falling at the pole, it's reflected back. Angle of incidence is equal to angle of reflection. What is normal here? Here principal axis is the normal. That is the case of concave, this is the case of convex. Now next is image formation. See, image formation by a concave mirror. See, object is at infinity. Here object is at infinity. So light ray is coming from infinity. So it is falling at this point. So it is parallel to principal axis. So it has to pass through principal focus. This is another light ray after reflection, again passing through center of mass. So again passing through principal focus. So here when it follows what? Law of reflection. Angle of incidence is equal to angle of reflection. So here we are getting an image. So what about this image? It's a highly diminished, point-sized image. Highly diminished. Diminished means small in size. Highly diminished, point-size image. Point-size image. Under what condition we are getting this image? When the object is at infinity. Now what happens here? If object is beyond C, this is C, so object is placed beyond C. So after reflection, one ray parallel to principal axis goes through the principal focus. Other ray which is falling on what? falling through the center of curvature gets reflected back. So we are getting what? We are getting what? An inverted image. We are getting what? Inverted. A dash B dash is what? Inverted, because the original object is straight, erect, but image is what? Inverted. So what you can say about the image? It is what? Real and inverted. Concave mirror forms mostly real images and inverted image. What about the size? Diminished. Real, inverted and diminished image. Diminished means small in size. Under what condition? When the object is beyond C. Here object at infinity. Object at infinity. Here object beyond C. Object beyond C. C stands for center of curvature. Okay, you have to draw this figure. You have to understand how to draw this figure. Next, object is at C. Object at C. At the center of curvature. So one ray goes passes through means parallel to principal axis. After reflection, it passes through principal focus. Another ray again what? Passes through what? Passes through principal focus. So what happens? When the ray passes through principal focus, it passes parallel to principal axis. When the reflected rays meet, you can see image. What you can say about the size of the image? Real and inverted. Real and inverted. Same size. Image size and object size both are same. So again, don't forget to give directed arrows, which is very important. Again next case. Again next case, where we have placed the object is placed between C and F. Center of curvature and principal focus. So one ray is passing what? From the object, it falls at this place and it gets reflected back. Why? Because it passes through what? Center of curvature. So it gets reflected along the same path. Another ray is falling here. Since it is parallel to principal axis, it must flow through principal focus. The reflected rays are meeting at this point. So what about the image? Real, inverted. Now see, magnified. Why magnified? Because image size is greater than object size. Now the next case, when the object is at principal focus. Object at principal focus. Now what you are seeing? One light ray is passing through what? Passing through center of curvature. The other one is what? Parallel to principal axis. So it passes through principal focus. Here the reflected rays never intersect. So we are assuming that if and only if reflected rays get intersect, then only we can see image. Here reflected rays are not cutting with each other or intersecting with each other. So we are assuming that they will meet at infinity. So where image is formed at infinity. Now the last case, this is a special case. Here object is placed between principal focus and pole. Object is placed between principal focus and pole. So what happens? See, one ray is what? This is the object AB. One ray is what? Passing through center of curvature, so it gets reflected back. So that is one ray. So when you draw the image, draw the ray backwards, you can see that it is passing through what? Pole. It follows what? Angle of incidence is equal to angle of reflection. When a light ray is incident at the pole, when the light ray is incident at the pole, what happens? Angle of incidence is equal to angle of reflection. So when the reflected rays are moved backwards, we can see they are diverging away from a point behind the mirror. So this is a special case in which a concave mirror forms what image? Virtual and erect. Virtual and erect. This is a special case. This happens only when the object is placed between principal focus and pole. This special case happens only when object is placed between principal focus and pole. So what are the two rays we are considering? One ray which is passing through center of curvature, and the other ray is falling at the pole. So with angle of incidence equal to angle of reflection. So this is the case where virtual and erect, where the image is formed behind the mirror. So all the cases so far we have discussed is shown here. First case, position of the object is at infinity, where image is formed at the principal focus. What is the size of the image? Highly diminished, point sized. What is the nature of image? Real and inverted. That we have seen the first case. Highly diminished, point size. Object is at infinity, image is at the principal focus. Always we will be using two rays. Whenever these rays after reflection intersect at a point, there will be image. Here the point of intersection is on the principal axis, but the size is not there for the image. So that is the reason why we are writing point sized image. Now what is the second case? Second case, beyond C. So where image is formed between principal focus and center of curvature. What is the size of the image? Diminished. What is the nature of the image? Real and inverted. See, object is beyond C. Two rays we are considering. One is parallel to principal axis, other is through center of curvature. After reflection, they meet at a point, and at that point we are getting what? A diminished image, inverted real. Image is formed between principal focus and center of curvature. Then third case, object is at C. So what happens to the position of the image? That is also at C. What is the size of the image? Same size. What is the nature of image? Real and inverted. Let's see. Object is at C. Image is also at C. Same size that of object. Image size is same size that of the object. And the image is formed at C. Okay, let's see the next case. Object is placed between center of curvature and the principal focus, where we are getting image beyond C. What is the size of the image? Enlarged. What is the nature? Real and inverted. See, object is between C and F. What we are getting? Two rays we are considering, one through the center of curvature, other is parallel to principal axis. After reflection, they are meeting at this point, and we are getting a real inverted image here. Now, next case, real inverted. What is the size? Enlarged or magnified. Magnified and enlarged both are same. Enlarged or magnified. Then next case, object at the principal focus. What is the position of image? At infinity. Highly enlarged, real and inverted. Let's see. Object at the principal focus. What are the two rays considering? One through the center of curvature, other parallel to principal axis. They are not meeting in the figure. We are assuming that they will meet at infinity. So what about the image? Highly enlarged or highly magnified, real, inverted, and image is formed at infinity. Now let's see the last case. Position of object between pole and principal focus. What is the position of the image? Behind the mirror. See, concave mirror forms image behind the mirror only under one condition. When object is placed between pole and principal focus. What is the size of the image? Enlarged. What is the nature of the image? Virtual and erect. What is the nature of the image? Virtual and erect. See, this is the object. and we are considering two rays, one passing through the center of curvature, other falling on the pole, so it gets reflected along the same angle. So when we move this light rays backward, we can see that they are diverging away from a point. That point is behind the mirror, and we are getting what image? Virtual and direct. Virtual images cannot be caught on the screen. If you place a screen there, you can't see that. That is the specialty of virtual, means not real. Okay, erect means straight. I hope you understood. Now, image formation by convex mirror. See, object is at infinity. So, light ray from object after reflection, it is moving away. But when you move this reflected ray backward, we can see they are deviating away from principal focus. So, what kind of an image it is forming? It is a point-sized image, highly diminished, virtual and direct. Virtual and direct, point size, highly diminished. Now, what happens at this case? Object is what? At this point, again we are considering two rays. And when we move it backward, we can see an image is formed between pole and the principal focus. What kind of an image? Virtual and erect and highly diminished. Let's see. First case, object is at infinity. Position of the image at the focus, behind the mirror, highly diminished, point size, virtual and direct. Object beyond infinity, image at the focus, highly diminished, point sized. Then here what happens? Image is virtual and erect. Highly diminished. Where image is formed? Behind the mirror. Highly diminished. See, between where object is placed between infinity and pole. First case is at infinity. Second case between infinity and pole, where image is formed between pole and principal focus. Diminished, virtual and erect. Now, mirror formula and magnification. See, this is new Cartesian sign convention. According to new Cartesian sign convention, there are certain rules. What are the rules? First rule, all distances should be measured from pole. It's a very important rule. All distances should be measured from pole. Distances should be measured from pole. So what is object distance? Some students will say it is the distance between object and pole. That is wrong. The object distance should be the distance from pole and object, because all distances should be measured from pole. Distances to the right side positive, distances to the left side negative. Now, when I take a measurement from pole, if the direction of incident light is coming opposite to my measurement, then you have to give minus sign. For example, in this case, this is the object. So, when you consider the object distance denoted by letter U, image distance V. What is the image distance? V. So, when I measure object distance, that is from pole towards the object, the light from the object is coming opposite to me. So, you have to give minus sign to the object distance in this case. Now, image is also formed at this side. So, when I take the image distance, it is from pole to this distance. So light from the image is coming opposite to my measurement. So again I have to give minus sign. Again I have to give minus sign. So distances towards the left side negative, right side positive. Distances above principal axis. See, height upward, it is what? Positive. Height below, what? Negative. So what are the rules? All distances should be measured from pole. Distances above principal axis positive, distances below principal axis negative, measurement or distances taken towards the right side positive, left side negative. So what is mirror formula? 1 by u plus 1 by v is equal to 1 by f, where v image distance, u object distance, f focal length. What is magnification? Magnification means its definition is height of image divided by height of object. What is magnification? Height of image divided by height of object. Magnification in mirror formula is minus v by u, where h dash is what? Height of object. H dash image height, h object height. Negative sign for real image and positive sign for virtual image. That is very important. Negative sign should be given for real image and magnification. Magnification m should be given negative sign for real image and magnification m should be given positive sign for virtual image. It's very important. Sign convention of spherical mirrors. All distances measured from pole of the mirror. Distances measured in the direction of incident light negative. Distances measured opposite to the incident light is what? Positive. Distances measured upward perpendicular to principal axis are positive. Distances measured downward perpendicular to principal axis is what? Negative. If there is a correction, distance measured in the direction of incident light positive. Distance measured opposite to the direction of incident light negative. Okay, then we have explained this. So if this is principal axis and if you consider this distance negative, this positive, because it is perpendicular above principal axis positive, perpendicular below principal axis negative. Now let's see the questions. So what is our first question? Define the principal focus of a concave mirror. Okay, I will answer it here. First question answer. What is the principal focus of a concave mirror? Principal focus of a concave mirror is the point on the principal axis, of the mirror, point on the principal axis of the mirror at which the light rays coming parallel to principal axis after reflection meet. This is the principal focus of a concave mirror. So what happens? This is concave mirror. This is the parallel rays. After reflection, they meet at this point. So this point on the principal axis is called what? Principal focus. This point on the principal axis is called what? Principal focus in the case of a concave mirror. Radius of curvature of a spherical mirror is 20 centimeter. So we are done with the first question. So let's see the second question. Radius of curvature of a spherical mirror is 20 centimeter. What is the focal length? Second question answer. Radius of curvature equal to twice the focal length. So what is focal length? Radius of curvature by 2. What is the radius of curvature here? 20 centimeter by 2. Radius of curvature is given as what? 20 centimeter. What is answer? 20 centimeter by 2. So answer is 10 centimeter. Focal length is what? 10 centimeter. I hope it is clear. Next, name a mirror that can give erect enlarged image of an erect and enlarged image of an object. Remember, name a mirror that can give erect and enlarged image. What is the answer? Concave. Concave mirror can give erect and enlarged image of an object. What is example? Shaving mirror. When the concave mirror is kept close to our face, what happens? We are seeing erect, enlarged image of our face. Any doubt? Why do we prefer convex mirror as a rear view mirror in vehicles? There are three reasons for that. What are the reasons? What are the reasons? Large field view. Large field view always forms erect, diminished image. What is the advantage of large field view? Large area you can cover in a small mirror. Always forms what? Erect image. So image is straight. What is the advantage of diminished? Because if you are going by a car or a bike and at the back side of your vehicle, if there is two KSRTC bus and auto rickshaw, still you can see that vehicles in the small mirror because it forms what type of image? Diminished image. I hope it is clear. So we are done with these 4 questions. So continue. Find the focal length of a convex mirror whose radius of curvature is 32 centimeter. So whether it is concave or convex, the formula is same only. R equal to 2F. So what is R here? 32 centimeter. What is F? F equal to what? R by 2. So 32 by 2, that is equal to 16 centimeter. Now, a concave mirror produces 3 times magnified real image of an object placed at 10 centimeter in front of it. Where is the image located? We have to find out the image position. So let's see. Magnification is 3 times. So what is the magnification? Magnification is 3 times. Enlarged real image. So if it is real image, real and inverted means what? Magnification has to be -3 of an object placed at 10 centimeter in front of it. See, this is concave mirror and we are placing an object at 10 centimeter in front of it. So what should be the object distance? It should be -10 centimeter. Why -10 centimeter? Because the distance is measured from pole. All the left side measurement should be negative. Now, what we have to find out? Where the image distance. So, we have to find out where image is located. Now, what is the formula for magnification? Magnification M equal to what is the formula? In mirrors, minus V by U. This is the standard formula for magnification. What is the magnification we got? -3. What is the image distance? Magnification M equal to minus V by U. So what is object distance? -10. So minus V by minus U is what? Minus V by U. What is U? -10. So it becomes what? -3 is equal to plus V by 10. So what is image distance? -30. What is image distance? What is the image distance? -30 centimeter. So there is a minus sign. Negative sign indicates that what? Image is what? Image is real. Image is real and image is formed in front of the mirror. Image is formed in front of the mirror. Why in front of the mirror? See, I am understanding that image is formed at this side at a distance of what? At a distance of 30 centimeter. Since why we are getting minus sign? Because it is in front of the mirror. If it was behind the mirror, I would have got a positive value for image distance. But I got a negative value of image distance. That means what? Image is in front of the mirror. Image is what? In front of the mirror. Now remember, magnification is what? -3, because it forms a real image. That means image will be inverted. So magnification has to give minus sign. So what is image distance? -10, because the distance is measured from pole, or the distance is to the left side of the mirror. So minus sign. Then for unknown quantity, for quantity to be found out, you should not give minus sign. So not minus sign, you should not give sign convention. See, here we have to find out image distance. So just simply keep what? Image distance as V. Don't give plus sign, minus sign. It is V. Then M equal to minus V by U. So minus of V by what is U? -10. Okay, I hope you are clear. And we got it as -30. Since it is -30, it's a real image and inverted. So image is formed in front of the mirror. I hope it is clear. Where is the image is located? Next, a ray of light traveling in air enters obliquely into water. Does the light ray bends towards the normal or away from the normal? Why? Now let's see. Ray of light is traveling in air, enters obliquely into water. So this is normal. This is in air. It enters what? With the angle of incidence I. This is air. It goes to what? Water. So rarer to air is rarer medium. Water is what? Denser. So it has to bend towards a normal. So this is the angle of refraction. This is the angle of refraction. It bends what? Towards a normal. Why? Because it travels from rarer to denser. Air is rarer medium, water is denser medium. So it bends towards a normal. Does the light ray bends towards a normal or away from the normal? What is the answer? Light ray bends towards normal. Light ray bends towards normal. What is the reason for that? When light ray travels from rarer to denser, it bends towards a normal, because denser medium is what? Thicker medium. So angle of refraction will be small. Denser medium. First question answer. Denser medium is a thicker medium. So angle of refraction will be small. So that is the reason why it is bent towards the normal. Angle of refraction will be small. Okay. Next, light enters from air to glass having refractive index 1.5. What is the speed of light in the glass? Speed of light in vacuum is 3 into 10 raised to 8. So second question. Refractive index, what is the formula? Speed of light in vacuum divided by speed of light in medium. So what we have to find out? What is the speed of light in the glass? So V equal to question mark. So what is the formula for V? V equal to C by N. What is C? 3 into 10 to the power 8. Because speed of light is a constant. Divided by what is the refractive index? 1.5. So 3 by 1.5 means what? 2 into 10 raised to 8 meter per second. Remember, there is no unit for refractive index. Find out from table 9.3 the medium having highest optical density. Also find the medium with the lowest optical density, that we have discussed at the time of taking that topic. Medium with the highest optical density means what? Highest optical density will have highest refractive index. Highest refractive index. So which medium is having highest refractiveness and highest optical density? Diamond. And the lowest optical density means what? Lowest refractive index. Lowest refractive index. Which medium is having lowest refractive index? What is the answer? Air. What was that? 1.0003, which is almost 1. Diamond, it was 2.42. Diamond refractive index what? diamond refractive index what? 2.42. I hope it is clear. You are given kerosene, turpentine and water. In which of these does the light travel fast? Use the information given in the table. So, first of all you should know which of these medium have lowest refractive index. It is based on the refractive index only we can say. So, let's do the fourth question. Refractive index of kerosene. Refractive index of kerosene from the table you should understand that it is 1.44. Then refractive index of turpentine. Turpentine refractive index is 1.47. Then refractive index of water is what? 1.33. This you should know. Now, so the lower the refractive index or optical density, the faster will be the higher will be the speed of light. So do remember that lower the optical density, higher will be the speed of light. Higher will be speed of light. Lower the optical density, higher will be speed of light. Lower the optical density, higher will be speed of light. Okay. So, which one is having lowest refractive index? I think water. So, speed of light will be maximum in what is the question? Find out the media having highest optic. Yeah, you are given. Use the information. In which of these does the light travel fastest? So, what? Water is having least refractive index. That means what? Least optical density. So, speed of light is maximum in water. Speed of light is maximum in water. Maximum in water. Speed of light is maximum in which? Water. The refractive index is diamond. What is the meaning of its statement? The meaning of this statement, I will explain that. The given value of refractive index suggests that speed of light in diamond is 1 by 2.42 times speed of light. See, speed of light is maximum in air, which is 3 into 10 raised to 8. Diamond refractive index is 2.42 means what? Speed of light in diamond is what? 1 by 2.42 times the speed of light. The given value of refractive index suggests that speed of light in diamond is what? 1 by 2.42 times the speed of light in vacuum. Speed of light in air or vacuum. So that means what? So what is our conclusion? The light travels most slowly in diamond because diamond is having high optical density, high refractive index. So the more the refractive index, lesser will be the speed of light. Diamond is having maximum refractive index means what? Speed of light will have minimum speed in diamond. I hope it is clear. Again, I am telling you, the diamond is having maximum refractive index means what? The speed of light will be minimum in diamond. So, refractive index and speed of light are inversely proportional. Our conclusion, refractive index and the speed of light are inversely proportional. So, Higher the refractiveness, minimum will be the speed of light. Okay. Define one diopter of power of lens. Let's see. One diopter is the SI unit of power of lens whose focal length is 1 meter. So what is power of a lens? We know that power of a lens is what? Reciprocal of focal length. If power is 1 diopter means what? Power equal to 1 diopter means what? Focal length has to be 1 meter. Next, a convex lens forms a real and inverted image of a needle at a distance. So second question answer. A convex lens forms a real and inverted image of a needle at a distance of 50 centimeter from it. So image distance is given. So what is image distance? Minus 50 centimeter. Okay. Where is the needle placed in front of the convex lens if the image is equal to size of the object? It is given that image distance is equal to object distance. If the image is equal to size of the, not image distance, image size and object size are equal. That means what? Magnification equal to 1. So what is magnification? Magnification formula is what? In lenses it is what? V by U. So magnification equal to 1 is equal to V by U. Also find the power of a lens. Okay. So magnification equal to 1 is equal to V by U. So that means what? U is equal to what? U equal to V. So what is object distance? Minus 50 only. If you cross multiply U equal to V. So what is V here? 1 equal to minus 50 by U, isn't it? So U equal to minus 50. U equal to minus, okay. Once you apply sign convention, U equal to minus 50. I hope it is clear. This line might be confusing. U equal to minus 50. So that is a object distance. Now, object distance is minus 50. What is the power of a lens? Power of a lens is reciprocal of focal length. We know lens formula. What is the lens formula? 1 by V minus 1 by U is equal to 1 by F. Now, what is 1 by U here? 1 by V 1 by V is what? Minus 50. So 1 by minus 50 minus 1 by U is what? Again minus 50. So 1 by minus 50 plus 1 by 50 is equal to 1 by F. That means what? 0 is equal to 1 by F. Ayo. 1 by V minus 1 by U equal to 1 by F. So 1 by what is image distance is what? 1 by minus 50 and the object distance is what? Minus 1 by V minus 1 by U. What is U? Minus 50 is equal to 1 by F. So second question, convex lens forms a real and inverted image of a needle at a distance of 50 centimeter from it. So it forms what? Real and inverted. So image distance has to be plus 50 centimeter. Where is the needle is placed in front of the convex lens if the image is equal to size of the object. So image size and object size are equal. Image size is equal to object size. So that means what? Magnification is equal to, magnification has to be 1. Now image is inverted. So magnification has to be minus 1. since image is inverted. I hope it is clear. This is the object. If this is the lens and we are getting what type of image? Inverted. So magnification will be what? Height of the image divided by height of the object. Here height of the image is negative because it is taken perpendicular down to the principal axis. So you have to give minus sign. So magnification there will be minus sign. Now magnification in lens formula is what? V by U. So minus 1 is equal to V plus 50 divided by U. So U equal to what? Minus U is equal to 50. That means U equal to what? Minus 50 centimeter is the object distance. Now what we have to find out? That is the position of the object. Where is the needle placed? In front of convex lens. So needle should be placed at 50 centimeter in front of the convex lens. Needle should be placed 50 centimeter in front of convex lens. Then also find the power of a lens. So first, power of a lens is reciprocal of focal length. So first of all, we should know what is the focal length. For that purpose, we are using lens formula. 1 by V minus 1 by U is equal to 1 by F. What is V here? V is plus 50. So 1 by 50 minus what is U? Minus 1 by 50. So minus 1 by 50 is equal to 1 by F. So 1 by 50 plus 1 by 50 is equal to 1 by F. That means 2 by 50 is equal to 1 by F. So 1 by 25 is equal to 1 by F. What is that? 1 by 25 is equal to 1 by F. So what is power? Power is equal to 1 by F. That is equal to 1 by 25. Now if you solve 1 by 25, power is 1 by 25, but power should be in diopter. Diopter means this should be in meter. So power is equal to 1 by 0.25. Why we are writing 0.25? Because 25 centimeter has to be converted to meter. So 1 by 20. Okay, I will write 1 by 25 by 100. Why 25 by 100? I am converting 25 centimeter to meter. So 100 goes to numerator. So 100 by 25, that is equal to 4 diopter. What is answer? 4 diopter. Okay. Next, find the power of a concave lens of focal length 2 centimeter. So power is equal to what? 1 by F. Power equal to what? 1 by F. Concave lens means what? Focal length. Remember, convex lens, focal length positive. Concave lens, focal length negative. So what is the focal length here? 2. So power equal to 1 by minus 2. So what is the power? Minus 0.5 meter. What is the power? Minus 0.5 meter is the power. Okay. I hope it is clear. So students, what we have learned so far? Light seems to travel in straight line. So light travels in straight line. Mirrors and lenses form images of object. Images can be either real or virtual. Virtual means not real. Okay, depending on the position of the object. The reflecting surface of all types obey the laws of reflection. What are the laws of reflection? Incident ray, reflected ray, normal, all should lie on the same plane. Angle of incidence is equal to angle of reflection. The refractive surface obeys the laws of refraction. What are the laws of refraction? Incident ray, refracted ray, normal should lie on the same plane. Then ratio of sine of angle of incidence to the sine of angle of refraction is a constant, and this constant is called refractive index, and this second law of refraction is also called Snell's law. New Cartesian sign convention are followed for spherical mirrors and lenses. What is that? All distances should be measured from pole. Distances above principal axis positive, below principal axis negative. Measurements taken left side of the mirror or lens negative. Measurements taken to the right side positive. Then mirror formula, what is that? 1 by u plus 1 by v is equal to 1 by f. Is the relation between the object distance u, image distance v, and focal length f of a spherical mirror. The focal length of a spherical mirror is equal to half of its radius. We know that r equal to 2f. So f equal to what? R by 2. The magnification produced by a spherical mirror is the ratio height of the image to the height of the object. M equal to hi by ho. What is hi? Height of the image. What is ho? Height of the object. A light ray traveling obliquely. Obliquely means what? At an angle from a denser medium to rarer medium bends away from the normal. Light ray bends towards the normal when it travels obliquely from rarer to denser. Light travels in vacuum with an enormous speed of 3 into 10 raised to 8 meters per second. Speed of light is different in different media. Speed of light is different in different media. Refractive index of a transparent medium is what? Ratio of the speed of light in vacuum to the speed of light in a medium. In case of a rectangular glass slab, refraction takes place at both air glass interface and glass air interface. Air glass interface means what? Light is traveling from rarer to denser. Glass air interface means what? Light to travel from denser to rarer. In both cases, there will be refraction. The emergent ray is parallel to the direction of incident ray that we have seen. What is refractiveness? Ratio sine of refractiveness. We have two equations: sin I by sin R, or what? See, speed of light in vacuum to speed of light in medium. Length formula is what? 1 by v minus 1 by u is equal to 1 by f. Gives the relationship between the object distance u, image distance v, and focal length f of a spherical lens. Power of a lens is what? Reciprocal of its focal length. SI unit of power of lens is diopter. Remember, focal length might be given in centimeter. You have to convert that to meter. Then only you should get power of lens. Okay, if focal length is 50 centimeter, power of lens is not 1 by 50. 50 centimeter has to be converted to meter. So power of lens will be what? 1 by, instead of 50, you should write 50 by 100. So 100 moves to numerator, power should be what? 100 by 50, 2 diopter. I hope it is clear. So these are the things that we have learned as of now. Now let's do some problems. Exercise. Which one of the following materials cannot be used to make lens? Water, glass, plastic, clay. So can we use water, glass, plastic, clay? So which one we should use? Remember, clay can never be transparent. Clay what? Can never be transparent. Transparent plastics are there. So plastic can be used, but we cannot use clay. Why? Because clay is not transparent. So D is the which of the following material cannot be used to make lens? What is the answer? Clay. Clay we cannot be used as lens. Why? Because clay is not transparent. Clay is not transparent. So we shouldn't be using clay because clay is not transparent. Image formed by a concave mirror is observed to be virtual, erect, and larger than the object. Where should be the position of the object? What about the image formed by concave mirror? Virtual, erect. I told you, generally concave mirror forms what? Real and inverted. Concave mirror forms virtual and erect magnified image only in one special case. What is that special case? I will write what is the answer. If the object is placed between pole of the mirror and its principal focus It will form what? It will form erect, virtual, magnified image. Erect, virtual and magnified image. Okay. Yeah, options are there between the pole of the mirror and its principal axis, between the principal focus and the center of curvature. So what is the correct answer? Between pole of the mirror and its principal focus. So option D is the correct answer. At the center of curvature wrong, beyond the center of curvature wrong, between principal focus and center of curvature is also wrong. So where you should keep the object should be kept between pole of the mirror and principal focus. Then only you will get virtual and erect and magnified image. In all other cases, you will get a real inverted image. Now, where should an object be placed in front of a convex lens to get a real image of the size of the object? See, object size and image size both are same. Object size and image size both are same. Now, that we have seen from the table, we know if we are keeping the object at twice the focal length, if you are keeping the object at the twice the focal length, then you will get an image what of the same size of the object. Remember, if you are keeping object at a position equal to twice the focal length from a convex lens, you will get an image of the same size of the object. So where you should keep it? At twice the focal length. Okay. Then a spherical mirror and a thin spherical lens have each focal length minus 50 centimeter. Mirror and the lens are likely to be. See, remember, focal length negative means what? It will be what mirror? Lens. Okay, focal length negative means what? It will be what kind of lens? Concave lens. Concave lens is similar to which mirror? Which mirror? Concave lens is similar to which mirror? I hope it is like convex mirror. The mirror is convex, but the lens is concave. So what is the correct answer? A spherical mirror and a thin spherical lens, each of focal length of what? Focal length is what? What? Minus 15. The mirror and the lens will be. So next question, a spherical mirror and a thin spherical lens have each focal length minus 15 centimeter. The mirror and lens are likely to be. See, what is the answer? Focal length is what? Minus 15 for lens. So it has to be what? Concave lens. And the focal length is negative means what? It has to be concave mirror. So what should be the answer? Both will be concave. Both the convex wrong answer because focal length of convex lens is what? Positive. The mirror is concave and the lens is convex. That is also wrong because convex lens should have what? Focal length positive. The mirror is convex but the lens is concave. Here concave lens is okay fine, but convex lens focal length will be what? Positive. So what is the only correct answer? Both concave. No matter. So that question is done. So what is the answer? For if focal length is negative, then it has to be what? Both concave lens and concave mirror. No matter how far you stand from a mirror, your image appears erect. The mirror is likely to be. Now remember, what is the answer? Either plane or convex. Because what is the reason? What is the reason? Plane mirrors and convex mirrors always forms what? Erect image. See, no matter how far you stand from the mirror, your image appears erect. Image is straight. The mirror is likely to be. Remember, plane mirror always forms what? Erect image. And convex mirrors also forms what? Erect image. Now, only concave. In concave mirror, you can expect erect image, virtual erect. That is a special case when the object is placed between pole and the principal focus. So, since it is always we are getting erect image means what? It has to be plane mirror or convex mirror. Okay. Now, which of the following lenses would you prefer to use while reading small letters found in a dictionary? So we have to use what? We have to use a lens that will be helpful for reading small letters found in dictionary. That is our question. Now, what are the options we have? Convex lens of focal length 50 centimeter, concave lens of focal length 50 centimeter, convex lens of focal length 5 centimeter, concave lens of focal length 5 centimeter. Now remember, see what is our purpose? We have to get a what? We have to read small letters. So that is our purpose. We have to read what? Small letters. Remember, convex lens is used as magnifying glass. So what should be our what we should be using? Convex lens of focal length what? 5 centimeter. See, convex lens of so concave lens we cannot use. What is the other option? One more convex lens is there of focal length what? 50 centimeter. So see, focal length of 50. So here we have two options with the convex lens. First is for 5 centimeter. 5 centimeter means what? Power is equal to what? 1 by 1 by 5 centimeter means what? 1 by 0.05. Isn't it? Because 5 centimeter has to be converted to meter. So what will be that? 100 by 5, that is equal to what? 20 diopter. 20 capital letter D. Now, convex lens of focal length 50 centimeter will be what? 1 by 50 centimeter converted to meter means what? 50 by 100, that is what? 1 by 2.5, which is equal to 2 diopter. So what is the better option? 20 diopter, since it has more power. Any doubt? So always remember, convex lens is used as what? Magnifying. So in the case of convex lens also we have two options, but we are preferring the third option because lesser the focal length, more will be the power. So one is giving 20 diopter power and the other one is giving only 2 diopter. So what we are preferring what we are preferring? We are preferring the option C, that is convex lens of focal length 5 centimeter. I hope it is clear. Next, name the type of mirror used in the following situation. Headlights of a car. For headlights of a car, what we will be preferring? Mirror. We are using concave mirror. Side rear view mirror is what? Convex mirror. Solar furnace is again what? Concave mirror. That we have discussed, right? So headlight concave mirror, rear view mirror convex, solar furnace is also concave mirror. Then we wish to obtain the erect image of an object using a concave mirror of focal length 15 centimeter. What should be the range of distance of the object from the mirror? What is the nature of the image? Is the image larger or smaller than the object? Draw a ray diagram to show the image formation in this case. So let's do. This is what we used to obtain a erect image of an object using a concave mirror. So special case, many times I had told you, concave mirror forms erect image only in one case, when the object is kept between pole and principal focus. So this is the case. This is the object. So one light ray is coming like this. Other one is passing through the principal focus. Through the center of curvature, it will get reflected to the same path. It appears to what? Diverge away from a point, and this is the image A dash B dash. The image is behind the mirror. This is the original object AB. So what we are getting from AB, there are two rays. One ray is what? After reflection from the mirror goes through the principal focus. one ray is passing through center of curvature, which again after reflection passes through the same center of curvature. When you move this line backward, it appears to diverge away from a point behind the mirror. So it forms what? Virtual erect magnified image. It forms what? Virtual erect magnified image. So where it is kept, we used to obtain the erect image of an object using a concave mirror of focal length of 15 centimeter. So the whole distance, this much distance between pole and the principal focus is what? 15 centimeter. What is distance between pole and the principal focus? Focal length. So what is a focal length? 15 centimeter. So we have drawn that image. What should be the range of distances of the object from the mirror? Object distance should be what? Between means lesser than 15 centimeter from the mirror. It has to be lesser than 15 centimeter, because to get a erect virtual image, we have to place the object between principal focus and pole. What is the nature of the image we are getting? What is the nature of image? Virtual erect magnified. Is the image larger? Yeah, magnified. What is the position behind the mirror? Image is formed behind the mirror. Okay, draw the ray diagram we have done. Next, one half of a convex lens is covered with a black paper. Will this lens produce a complete image of the object? Verify your action experimentally. Explain your observation. See what happens here. One half of a convex lens. So this is convex lens. One half we are covering. Okay, one half we are covering. One half of the convex lens we are covering with the black paper. Okay, black paper. Okay, this white thing is the black paper. Will this lens produce a complete image of the object? That is a question. Now, even if you cover it with a black paper, see, the lens will produce a complete image. Lens will produce what? Complete image. But the image will be of lower intensity. Image will be of lower intensity. Image will be of lower intensity and brightness. What is the reason for that? Because lower part of the image, lower part of the lens, rays are blocked. So intensity will be lesser. There will be complete image, but the intensity won't be there when you cover this lens with a black paper. So let's see. This is F1. We are placing an object beyond F1. AB is the object. So one light ray is coming here. Then after reflection, it passes through second focal point F2. Then here we can see image A dash, B dash. So where image is gone, this is the one light ray, this is another light ray. So what about image A dash, B dash? Same size. Image is there, but some part of light ray is coming through the what? This covered face. So intensity will not be there. There will be image formation, but the intensity will not be there. So that is a case with when you cover a convex lens with a black paper. Okay, done. Then an object of 5 centimeter in length is held 25 centimeter from a converging lens of focal length 10 centimeter. Draw the ray diagram and find the position, size and nature of the image formed. Let's see. Object of 5 centimeter. Okay. Let me take the new page. An object of 5 centimeter. So what are the given data? Let's see. Convex lens. We are using what? Convex lens. This is f1. This is 2f1. Where the object is placed. Object 5 centimeter length is placed 25 centimeter away from a converging lens. Converging lens is what? Converging lens is what? Converging lens means convex lens. Convex lens of focal length what? 10 centimeter. Object of what? 5 centimeter. So height of the object is what? So let's see the given data. So given data says that height of the object 5 centimeter. 5 centimeter. Then what are the data? 25 centimeter away. So object distance is what? Minus 25 centimeter of a converging lens of convex lens. Convex lens focal length is what? Positive. So plus 10 centimeter. Remember convex lens focal length positive. Draw the ray diagram. So this is the object. See one light ray. After reflection, it passes through F2. It passes through what? F2. And the other one passes through the optical center. It meets here. So here you can see an image A dash, B dash. This is the object AB. I forgot to give the directed arrows, which is very important. Okay, so this is the case where we are getting the image. So image is formed between F2 and 2F2. This will be what? 2F2. Image is formed between F2 and 2F2. Now, we doesn't know what is the image distance. What is the image distance equal to? Question mark. Focal length is what? 10 centimeter. So we know that 1 by f is equal to what? 1 by v minus 1 by u. So what is 1 by f? 1 by 10. What is 1 by v? 1 by v doesn't know. Minus 1 by u is what? 1 by minus 25. So 1 by 10 is equal to 1 by v plus 1 by 25. So 1 by v is equal to 1 by 10 minus 1 by 25. If you take LCM, 1 by v is equal to 250. If you cross multiply 25 minus 10, so 1 by v is equal to 15 by 250. Answer will be 15 by 250. That if you divide by 5, what we will get? 3 by 50. So V is equal to, that is 1 by V equal to 50 by 3. So V equal to 16.67 centimeter. 16.67 centimeter. Now again, one more point is that we have to find out the size of the image. So let's see what is magnification. Height of the image divided by height of the object. Is the magnification given? Magnification m is equal to height of the image divided by height of the object, which is equal to what? In lens, what is the formula for magnification? V by u. Now we have to find out image size. Image size hi is equal to ho into height of the object into v by u. Height of the object into v by u. What is the height of the object? It is 5 centimeter. Into what is image distance? Medicines we got it right, 16.67, or I should take 50 by 3. By what is the object distance? Minus 25. So what is the answer? 5 into 50 by 3 into minus 25. Sorry. 5 into 50 by 3, denominator minus 25. So what is the answer? 5 into, it becomes what? 2, there is a minus sign. So 10 by minus 3, that is equal to minus 3.33 centimeter. 10 by minus 3, that is equal to minus 3.33 centimeter will be the height of the image. See here we are getting minus sign. Why minus sign? Because it is what? Inverted image. So what? Image height will be negative. Okay, minus 3.33 centimeter. So that was about that question. I hope it is clear. Next question, a concave lens of focal length 15 centimeter, the 11th question. Concave lens of focal length of 15 centimeter forms an image 10 centimeter from the lens. How far is the object placed from the lens? Draw the ray diagram. See, you have to check whether you have to draw the diagram or not. Some question you have to draw the diagram. So that is very important. Let's see. It is what lens? Concave lens. So I am drawing a concave lens. Okay, of focal length 50 centimeter. So focal length is what? 15 centimeter. Concave lens forms, focal length is what? Positive. Yeah. Concave lens, focal length will be what? Negative. Convex lens, focal length positive. Concave lens, focal length negative. Image 10 centimeter from the lens. So what is the image distance? Minus 10. Okay, how far is the object is placed from the lens? So V equal to what? U equal to what? Question mark. So that is our target. Let's see. So first of all, we know that 1 by V minus 1 by U is equal to 1 by F. So object distance we don't know. So for the unknown quantity should not be applying sign convention. That is very important. You should not apply sign convention to the unknown quantity. So 1 by minus 10 minus 1 by U is equal to 1 by F. So 1 by, what is F? F is minus 15. So 1 by minus 10 minus 1 by U equal to 1 by minus 15. So minus 1 by 10 plus 1 by 15 is equal to 1 by U. So if you take LCM, 150 minus 15 plus 10 is equal to 1 by U. So minus 15 plus 10 is what? Minus 5 by 150 is equal to 1 by U. So divide minus 1 by 30 is equal to 1 by U. So U is equal to minus 30 centimeter. So what is object distance? Minus 30. What is object distance? Minus 30 centimeter from the lens. Now, this is the principal axis. Now, the object distance is what I got? Minus 30. So, object is at the same size of the same side of the image. Image distance is minus 10. So, this is the object distance. Object distance is what? Minus 30, which is what? Focal length is what? 15. So object should be at this point. And then what about the, no, let me increase the size. Focal length is what? 15. So this is the, let this be the focal length is 15. And the image principal focus is what? F. So this will be the pole. So this will be the focal length minus 15. Object is kept to what? Minus 30 centimeters. So this here should be the object. It is of distance what? Minus 30. So this distance is what? Minus 30. That is, when you write it, you will write as 30. Now, one ray is coming what? Here. It will be going like this. Another ray, it should be going through the focus. Now another ray should be passing through the optical center. Here rays are intersecting. So here you can expect what image. What is the image? A dash, B dash. What is the image? A dash, B dash. Image is what? A dash, B dash. What is this? Object is what? AB. Image is what? A dash, B dash. Now, what is the image distance we got? Image distance is minus 10. So, this will be the image distance V equal to 10 centimeter. I am not writing minus 10, it is 10 centimeter, but when we apply sign convention, it is minus 10. Now, image distance is lesser than focal length, because what is the focal length? Minus 15, that is 15 centimeter. Focal length is what? Focal length is what? 15 centimeter. I hope this data is clear for you. Focal length 15 centimeter, object distance 30 centimeter, and where we got image distance 10 centimeter. I hope it is clear. This is the ray diagram. Don't forget to give arrow mark. Directed arrows are compulsory that you have to give. And what about the image? Real, sorry, not real, virtual, erect, and diminish. Virtual, erect, and diminish. Now, since focal length is 15 centimeter, we are understanding that if object is kept to what? 2 times the focal length, 2f. Okay, and where the image is found out? Between pole and principal focus. What kind of an image we are getting? Virtual, erect, diminished. Virtual, erect, and diminished. Diminished image we are getting. Okay. We are getting what? Diminished image. I hope it is clear. Erect image, diminished image. Erect image and diminished image. Then I think there was one more question. An object is placed at a distance of 10 centimeter from a position and nature of the image. An object is placed at a distance of 10 centimeter from a convex mirror of focal length 15 centimeter. I think we can do it here itself. Object is placed at a distance of 10 centimeter from a convex mirror. So 10 centimeter from a convex mirror is the object. So what is the object distance? U equal to minus 10. U equal to minus 10 centimeter. From a convex mirror of focal length of what? Focal length convex mirror. So what is the focal length? It has to be what? Minus sign. So find the position and nature of the image. So U equal to minus 10. Focal length is equal to what? Plus 15. Okay. Object distance is minus 10. What is focal length? 15 centimeter. Why plus 15? What kind of image is what? Convex mirror. So this is convex mirror. This is the convex mirror. So where will be principal focus here? So focal length has to be what? Positive. So focal length is what? Plus 15 because the measurement is taken to the right side. Find the position and the nature of the image. So what is the mirror formula? 1 by U plus 1 by V is equal to 1 by F. Position and the nature of the image. So what we have to find out? 1 by V is equal to what? 1 by F minus 1 by U. So 1 by focal length is what? 1 by 15 minus 1 by minus 10. So 1 by 15 plus 1 by 10. So what is 1 by V equal to? 1 by V is equal to 150. Then cross multiply 10 plus 15. That is 25 by 150. What is 25 by 150? 1 by 6. So image distance equal to what? 6. What is image distance? 6 centimeter. What is image distance? 6 centimeter. See, we got plus 6. So image distance is what? Positive. So we are getting the image behind the mirror. So where is the image is? We are getting image behind the mirror. Image behind the mirror. Image is what? Behind the mirror. So image is what? Virtual and erect. Behind the mirror means what? Virtual and erect. See, in the previous case, what we got? This is convex mirror and we are getting image what? Image distance positive. So image distance is to the right side. So it forms what? Virtual and erect image. Then here what we got in the previous example, we got what? Object image in the same side of the object. So what was the image? Real, erect and diminished. If you are getting at this side, it will be what? It will be what? Virtual and erect. So here we got at the same side. So real, erect and diminished image. Then magnification, next question. The magnification produced by a plane mirror is +1. What does it mean? The magnification is +1. Magnification is +1 means both the object and image is of same size. Is of same size. Since magnification is positive, image is erect and virtual. Magnification is what? Erect and virtual. Magnification positive means what? Erect and virtual image. Magnification is +1. So what? Erect and virtual image. Okay. Magnification positive means what? Erect and virtual image. Next, an object 5 cm in length is placed at a distance of 20 cm in front of a convex mirror. 14th question. An object of 5 cm in length. I think I had done a mistake. Here what? It is what? Virtual. I told it real, I think. It's a virtual image. Magnification is what? Positive means what? Image will be virtual image. Virtual image. I said it wrong, I think, last time. Magnification is positive means what? It is what image? Virtual image. Okay, coming back. Magnification positive means what? Image is virtual. Do remember that. An object 5 cm in length is placed at a distance of 20 cm in front of a convex mirror of radius of curvature is 30 cm. So let's see. Radius of curvature is what? 30 cm. What kind of a mirror is this? It is in front of what mirror? Convex mirror. Convex mirror radius of curvature is +30. Then R equal to what? 2F. So focal length has to be what? R by 2. So focal length has to be 30 by 2. So focal length has to be what? +15 cm. Convex mirror, that object of 5 cm in length. Object distance is what? Height of the object is +5 cm. Okay. Distance of 20 cm in front of a convex mirror. So distance, object distance is what? -20 cm. Now what we have to find out? Find the portion of the image, its nature and size. So V equal to question mark. So what are we dealing about lens or mirror? Mirror. So mirror formula is what? 1 by V minus 1 by U is equal to 1 by F. So 1 by V is equal to 1 by U. Sorry, mirror formula 1 by V plus 1 by U equal to 1 by F. So 1 by V is equal to what? 1 by V is equal to 1 by F minus 1 by U. So 1 by V is equal to, what is 1 by F? 1 by 15 minus 1 by U is what? 1 by minus 20. So 1 by 15 plus 1 by 20. So 15 into 20 is what? 300. If you cross multiply 20 plus 15, that is 35 by 300. 35 by 300. So if you divide it by 5, it will be what? 7 by 60. That is 1 by V. So V will be what? 60 by 7. If you do 60 by 7 calculation, your answer will be 8.57 centimeter. Now, magnification M is equal to what? Height of the image divided by height of the object. What is height of the image? Image, that is equal to what? In mirror, what is the magnification? Minus V by U. We should know height of the image, that is equal to minus V by U into height of the object. What is minus V by U? Minus of, what is the V value? 8.57 divided by, what is object distance? Object distance, how much we got? I don't remember. Yeah, minus 20 into height of the object is what? Plus 5. If you solve that, you will get 2.14 centimeter. This is the height of the image. So object image size is reduced. So what about the image? Image is what? Image is what? Image is diminished. And what kind of a magnification we have? Magnification is what? Minus V by U. And minus V by U is a magnification in mirror. But our answer for minus V by U is what? It is positive. Since minus sign will be gone, right? Because both are negative, that means what? It becomes positive. Since magnification is positive, what kind of an image? Virtual image. Virtual image. And then what? Erect. Magnification is positive, so erect, virtual. And diminished. Why diminished? Because the image size is 2.14 only. Object size is what? Object size is greater. What is object size? 5. So diminished, erect, and virtual. I hope it is clear. Then 15th question. Okay, let's do one small one. Find the focal length of a lens of power minus 2 diopter. What type of a lens is this? Since focal length power is negative means what? Power negative means what? It is concave lens. Lens is concave lens. What is focal length? Reciprocal of power. Okay, reciprocal of power. So focal length is equal to what? 1 by minus 2. Okay, 1 by minus 2 diopter. So what is 1 by minus 2? Focal length is equal to what? Minus 0.5. Or focal length is equal to minus 50 centimeter. Focal length is negative means what? It is concave lens. Any doubt? Any doubt? I hope it is clear. Next, a doctor has prescribed a corrective lens of power 1.5D. Find the focal length of the lens. Is he described lens diverging or converging? Focal length is what? Positive. That means what? It is what kind of a lens is this? Focal length is positive means what? Or focal length of power positive means what? Focal length positive. Focal length, that is power positive. Both are positive means what? It is convex lens. Convex lens is what? Converging lens. Now we have to find out the focal length, right? So focal length is equal to what? 1 by 1.5. Okay. 1 by 1.5. So what will be, if you do that 1 by 1.5, it will be what? 10 by 15. That is equal to what? 2 by 3, right? 2 by 3. If you solve that, it will be 6.66 meter. 0.66 meter. Or you can say 66 centimeter. Since focal length is positive, it is what lens? Convex lens. I hope it is clear. Next, an object of size 7 centimeter. Object of size 7 centimeter is placed. So height of the object is what? 7 centimeter. Is placed at 27 centimeter in front of a concave mirror. So in front of concave mirror means what? Object distance is minus 27 centimeter. Focal length of concave mirror will be what? Negative minus 18 centimeter. At what distance from the mirror should the screen be placed so that a sharp focused image can be obtained? That means image distance. So image distance we have to find out. What kind of a mirror is what? Concave mirror. Concave mirror. So what we have to do? 1 by V, 1 by U plus 1 by V is equal to 1 by F mirror equation. 1 by V we should find out. So what is 1 by F minus 1 by U? 1 by minus 18 minus what is 1 by U? 1 by minus 27. So 1 minus 1 by 18 plus 1 by 27 is the answer. So if you solve that, we will get minus 27 plus 18 divided by 18 into 27. Okay. So minus 27 plus 8 is what? Minus 9 divided by 18 into 27. So minus 9 here it becomes 2. So minus 1 by 54. So 1 by V equal to minus 1 by 54. So V equal to minus 54 centimeter. Okay. Now we have to find out the position, right? So magnification M is equal to what? Height of the image divided by height of the object, that is equal to mirror magnification minus V by U. Height of the object is what? 7. Height of the image we don't know. Minus image distance is what? Minus 54. Minus 54 divided by what is object distance? Minus 27. So minus becomes plus. Still there is an outer minus. What is height of the image? 7 into, it becomes what? 7 into minus 2. What is height of the image? Minus 14 centimeter. Minus 14 centimeter. Now magnification, what we got? Magnification is minus, right? Magnification is what? Height of the image minus 14 divided by height of the object is what? 7. Magnification is minus 2 centimeter. Magnification is minus means what? It is real and inverted. And magnification is minus 2. So what happens? The image of object is magnified, but since it is minus 2, it is what kind of an image? Real inverted. Real inverted magnified 2 times. Always remember magnification positive virtual image, magnification negative real image. Real inverted magnified 2 times. Magnified 2 times. That means image size is 2 times that of object size. Any doubt? Any doubt? Any doubt? I hope we have done all the questions, right? Yeah. Done. Okay. Yeah. Let's continue. Next topic is refraction. What is refraction? Change in direction of light when light passes from one medium to another. What is the reason for refraction? Caused by change in speed of light in different media. See, when light travels from one medium to another, see, this is a separation between two media. This is normal and this is the incident ray. See, this is the incident ray. making an angle of incidence I with the normal. So this is normal, this is incident ray. Incident ray makes an angle I with the normal. Now see, this is the refracted ray. So this is angle of refraction. This is refracted ray. So what you are understanding? See, light rays traveling from light ray traveling from denser means thicker. Denser medium means thicker to rarer. Rarer means thin media. Rarer media means thin media. So light ray is bending away from the normal. When light ray travel from denser to rarer, light ray is bending away from normal. So that is the case when light ray travel from denser to rarer. What happens? Light is bending away from normal. See, if there was no refraction, light ray is supposed to go through this way. But because of refraction, there is a bend in the path of the light ray. This bend in the path of the light ray is called what? Refraction. The change in the direction of light when it passes from one medium to another. See, I'm doing a small correction in the definition. Obliquely. Obliquely means at an angle. Why I am so particular about that correction? Suppose if a light ray, this is the normal. Suppose light ray falls through the normal. Now what happens? Angle of incidence is equal to angle of refraction is equal to 0 degree. There is no refraction. Why? Because light ray is passing through normal. For refraction to happen, light ray should fall obliquely. Obliquely means at an angle. So I am just writing that for refraction to happen, light ray should fall obliquely. Obliquely means what? At an angle. Light ray should fall obliquely means at an angle. If light ray is not falling through the normal, or when the angle of incidence is 0, then angle of refraction also will be 0. So that is the reason why we are saying that for refraction to happen, light ray should fall obliquely, means at an angle. Now let's see the other case. I will draw a simple figure. Again, medium separation, normal. See, this is rarer medium, rarer. So light ray is coming from rarer to denser. See what happens? Light ray bends towards normal. Light ray bends towards normal. So here what happens? Angle of refraction lesser than angle of incidence. Under what case? Light ray travel from rarer to denser. In the previous example, what we have seen? Angle of refraction greater than angle of incidence. Under what condition? When light ray travel from denser to rarer. When light ray falling through the normal, then there is no refraction. Angle of incidence is equal to angle of refraction is equal to 0. Any doubt? So that you can see in this figure. There is a glass slab. So this is what air, which is a rarer medium, means thinner. Then it is getting into a denser medium, that is glass. So what happens? Light ray bends towards normal. This is angle of incidence I1. This is angle of refraction R1. So it bends towards the normal. The dotted line is the line which light ray is supposed to go through when there is no glass slab. Again, this ray is incident at this normal with making an angle of incidence I2. When it comes out, the angle of refraction is what? R2. Here what happens? Denser to rarer. So there are two refraction here. First case, rarer to denser. This is denser. Then what? Denser to rarer. In the first case, it bends towards normal, since it is rarer to denser. When the same light ray passes denser to rarer, it bends away from normal. Any doubt? It's an example for refraction. What is this dotted line? This is the original path which light ray is supposed to undergo. But because of refraction, light ray have been moved some place, some distance. This distance is called what? Lateral shift. Lateral shift. That is the change in light ray path due to refraction is called lateral shift. I hope it is done. Light ray bends towards normal when entering a glass from air. Light ray bends away from normal when leaving glass to air. Glass to air means what? Denser to rarer. Leaving glass to air means what? Denser is glass, denser to entering glass from air. Sorry. Entering glass from air means what? Rarer to denser, because from air to glass is denser. Now, leaving glass to air means what? Denser to rarer. Sorry. Emergent ray is parallel to incident ray but laterally displaced. That we have shown in the figure. That lateral displacement is called lateral shift. Light ray have been laterally displaced. See, emergent ray is parallel to incident ray. That you can see. Emergent ray is parallel to what? Incident ray. But it has been laterally displaced. This lateral displacement is lateral shift. By lateral displacement, if there were no glass slab, it would have gone through this path. Now, because of refraction or because of glass slab, light ray has been laterally displaced. Now, laws of refraction. See, light ray is traveling from rarer to denser. So, it bends what? Towards normal. Angle of incidence greater than angle of refraction when light ray travel from rarer to denser, medium 1, medium 2. Now, what is the reason for refraction? There are two reasons. Speed of light is different in different media. 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 That is the reason behind refraction. Consider a ray of light traveling from medium 1 into medium 2 as shown in the figure. Let V1 be the speed of light in medium 1 and V2 be the speed of light in medium. So, in rarer medium, speed is V1. In denser medium, speed is V2. The refractive index of medium 2 with respect to medium 1 is given by the refractive index of medium 2 with respect to medium 1. See, at first we are writing medium 2. The medium in which light ray have entered, that is medium 2. The medium from which light ray started is what? Rightmost. So, from medium 1 it is entering medium 2. So, how I am writing? Refractive index of the medium in which light ray have reached, that is written first, medium 2. The medium from which light ray have started, that is medium 1. That is equal to what? Speed of light in medium 1 divided by speed of light in medium 2. This symbol is called refractive index. This symbol is called refractive index. The refractive index of medium 2 with respect to medium 1 is given by the ratio of speed of light in medium 1 to speed of light in medium 2. This is usually represented by the symbol N21. This can be expressed as an equation as what? N21 is equal to speed of light in medium 1 divided by speed of light in medium 2, that is V1 by V2. By the same argument, refractive index of medium 1 with respect to 2. Medium 1 with respect to 2 will be what? Speed of light in what? Medium 2 divided by speed of light in medium 1, that is V2 by V1. If medium 1 is vacuum or air, then the refractive index of medium 2 is considered with respect to vacuum. This is called absolute refractive index. So when we will have absolute refractive index, if first medium is air, then we call the refractive index of the second medium as what? Absolute refractive index. So when the first medium is air, we call the refractive index as what? Absolute refractive index, or it is simply represented by N2. What is that? N2. Now, so remember what is refractive index? If light ray travel from, again I am repeating, this is normal, this is incident ray making an angle of incidence I, this is a refracted ray making an angle of refraction R, this is medium 1, medium, this is medium 2. So, how to write this? The medium in which light ray is entered is written first. The medium from which light ray started is written second. So, N21 is equal to what? V1 by V2. So, what is what is refractive index of medium 1 with respect to 2? V2 by V1. And remember, N21 is equal to 1 by N12. This relation you should remember. If one of the medium, if first medium is air, we call the, if first medium is air, we call the second medium refractive index as absolute refractive index. If you are using the term absolute refractive index for a medium, then you should understand that the first medium is what? Air. Okay. Now, if speed of light in air, c is the speed of light in air, the speed, then v is the speed of light in medium, then refractive index of medium is equal to what? Speed of light in vacuum divided by speed of light in medium. What is this? N suffix m stand for refractive index of the medium. For example, what is the refractive index of water? So, refractive index of water is equal to what? Or absolute refractive index of water? Speed of light in vacuum divided by speed of light in water. That will give what? Refractive index of water or absolute refractive index of water. The absolute refractive index of a medium is simply called as its what? Refractive index. Even though it is absolute refractive index, we call it as what? Simply refractive index. Incident ray, refracted ray, and normal at the, now laws of refraction. Next point, laws of refraction. What is laws of refraction? Incident ray, refracted ray, and the normal at the point of incidence all should lie on the same plane. See, suppose one light ray is traveling from denser to rarer. Denser to rarer. So what happens? Initial angle of incidence is small, denser medium. So in the second medium, angle of refraction is what? Angle of refraction greater than angle of incidence when light ray travel from denser to rarer. This is what? What is denser? This is first medium, this is second medium. So which medium light ray have reached? Second medium. From which medium it has started? First medium. That is equal to what? V1 by V2. Any doubt? That's N21 is termed as, we have to pronounce it as refractive index of second medium with respect to first medium. Any doubt? Now listen, incident ray, refracted ray, normal, all these 3 points, all these 3 lines I have drawn on the same board. No line is penetrating into the board or coming out of the board. That means what? Incident ray, refracted ray, normal, all should lie on the same plane, which is same as what? Law of reflection. Incident ray, reflected ray, and normal all should lie on the same plane in reflection also. So, law of reflection and the law of refraction, one law is same for both reflection and refraction. What is that? Incident ray, refracted ray, and normal should lie on the same plane in law of refraction. Law of reflection, incident ray, reflected ray, and normal all should lie on the same plane. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant. This law is called Snell's law. Ratio of sine of angle of incidence to the sine of angle of refraction is a constant. This constant is called what? refractive index. So let's see. Sin I by sin R is equal to constant. So light ray is traveling from denser to rarer. So refractive index of reached medium, second medium, started medium, first medium is equal to sin I by sin R. Is equal to what? Sin I by sin R. So refractive index of second medium with respect to first medium is equal to sin I by sin R. I can write the bring the other equation also here. What is that? Is equal to what? V1 by V2. Any doubt? I hope it is clear. This constant is called what? Refractive index, sin I by sin R. This is called Snell's law. What is Snell's law? Ratio of sine of angle of incidence to the sine of angle of refraction is a constant. That constant is what? Refractive index. Refractive index, ratio speed of light in first medium to that of second medium, N21 equal to V1 by V2 sin I by sin R. Absolute refractive index with respect to vacuum, N equal to C by V. Optically denser medium means what? Medium with higher refractive index. If a medium has high refractive index, we call it as what? Denser medium. If a medium has low refractive index, we call it as what? Rarer medium. Optically denser means what? Denser medium. Optically rarer means what? Rarer medium. Rarer medium will have low refractive index. Denser medium will have high refractive index. Then ratio sine of angle of incidence to the sine of angle of refraction, Snell is equal to a constant called refractive index. That law is called Snell's law. Absolute refractive index means what? Refractive index of a medium with respect to air. Now, absolute refractive index of some material media. Air refractive index 1.0003. We almost take it as 1. Material medium, another material medium, Canada balsam. What is refractive index? 1.53. It's a different elements. Ice 1.31. Okay, let me mark the important one. Air 1.0003, which is almost equal to 1, is very important. You should by heart. Then water, ice is 1.31. It is not that important. Water, you have to remember 1.33. Alcohol, more refractive index 1.36. Kerosene 1.44. Fused quartz 1.46. Turpentine that we use in paint work 1.47. Oil benzene 1.5. Crown glass 1.52. Canada balsam 1.53. Rock salt 1.54. Carbon disulfide 1.63, dense flint glass 1.65, and ruby 1.7, sapphire 1.77, diamond 2.42. Very important. Diamond is having 2.42 refractive index. So it is what? Optically what? Optically denser. Optically denser. So very high refractive index. Diamond is the hardest substance. Hardest substance in the universe. Diamond. Diamond is the hardest substance. You don't have to by heart this table, but remember water refractive index 1.33, air 1, diamond 2.42. Air minimum refractive index, diamond maximum refractive index, and water refractive index 1.33. Now, spherical lenses. This is a convex lens and this is a concave lens. See, let me show you how we are getting this lens. There are two spherical surfaces. Okay. Now, what I am doing is that I am just cutting certain portion. So, now I got what? A convex lens. See, what is the specialty of convex lens? Originally, it was like this. So, convex lens has two center of curvature. It has what? Two center of curvature. Two focus also. Two principal focus, two center of curvature. Okay, the same thing with the concave. How concave lens is formed? This is one sphere, this is another sphere. So I am making this portion and I am removing this section. Okay. See what I am getting? A concave lens. This is a concave lens. Again what? Two center of curvature, two principal focus. Remember, mirror is having only one center of curvature, one principal focus. But lens is having two center of curvature, two radius of curvature, two principal focus. Because it is a combination of two spherical surfaces. First one is convex lens, second one is what? Concave lens. This is the first focal length, this is the second focal length, f1 and 2f1. Okay. So original focus is 2 times f1. Okay. So convex lens what? Exact opposite to mirror. So convex lens is converging lens. Convex lens is what? Converging. And concave lens is what? Diverging. Concave lens is diverging. See, rays diverging away. See, rays are converging. Types: convex lens, converging, concave lens, diverging. Thicker at the middle than edges. Convex lens, thicker at the middle than at edges. Concave lens is what? Thinner at the middle than edges. So, middle portion thicker, convex. Middle portion thin, concave lens. Important terms: optical center, center point of the lens. Principal axis, straight line passing through optical center. Principal focus point where rays parallel to principal axis converge in the case of convex. Diverge, appears to diverge. Actually, it is not diverging, it appears to be diverging in the case of what? Concave lens. So, convex lens, converging lens, similar to what? Concave mirror. Concave lens, diverging lens, similar to what? Convex mirror. Focal length. So, remember, concave lens similar to what? Concave lens similar to convex mirror. Convex lens similar to concave mirror. So concave lens and convex mirror are what? Diverging. Convex lens and concave mirror are what? Converging. So do remember that. Image formation by convex lens. See, straight line parallel to principal axis. After reflection, converges to a point on the principal axis. Another line straight through principal focus f1. So it goes parallel to principal axis on the other side. I hope it is clear. First one is what? Falling at the convex lens. So it passes through principal focus f2. Second, falling through f1. So it goes parallel to principal axis at the other side. Now, passing through optical center means what? It will go without any deviation because it is falling what? It is falling along the normal, so no refraction. So again, the converging action of convex lens. Here the image formation of convex lens. Where image is formed, image is placed. Okay, first of all, where object is placed beyond 2f1. So one light ray falling at this place, what happens? Passes through focus, other through optical center going here. So when the refracted rays converge, no, there will be image. Image is what? What about the image? Diminished, real, inverted. Remember, concave mirror forms real and inverted. Convex lens also forms real and inverted. I hope it is clear. What is U? Object distance. What is V? Image distance. Remember mirror equation. What was mirror equation? 1 by U plus 1 by V is equal to 1 by F. For you to remember this, what is mirror equation? 1 by U plus 1 by V is equal to 1 by F. In lens, the equation is 1 by V minus 1 by U is equal to 1 by F in lenses. This is the equation. What is U? Object distance, where U, object distance u equal to object distance v image distance. V equal to image distance. U object distance, V image distance. I hope it is clear. Done, right? Next, object is at 2f1. See, two rays are coming, one through the optical center, other falling at the end of the lens. So they are converging at 2f2. Any doubt? So what happens? Same size, right? Real and inverted. When the object is at 2f1. Now, when the object is between 2f1 and f1, what happens? We are getting a magnified image beyond 2f2. When the object is between 2f1 and f1, in the case of what is f1 and 2f1? F first focal length, 2 times first focal length. Okay, other side we have second focal length, 2 times second focal length. So, when the object is between f1 and 2f1, where image is formed? Beyond 2f2. And what about the size of the image? Real, inverted, magnified. Real, inverted and magnified image. I hope it is clear. Then next thing, object is at f1. So what happens? See two rays, they are not intersecting. So we will assume that they will intersect at infinity. So real, inverted, magnified here. Real, inverted, magnified. Now the special case in convex lens. There was a special case in concave mirror also. When object is placed between pole and principal focus, image was what? Virtual and direct. Here also, when the object is placed between optical center and first focal length, what happens? Image is what? Virtual, erect, magnified. Image is what? On the same side of the object. Image on the same side of object. What kind of an image? Virtual, erect, magnified. This is a special case in which convex lens forms a virtual image. I hope it is clear. So, in order to get a virtual image from convex lens, the object should be placed between f1 and optical center. Please do remember that. Okay, it's a virtual and erect image. See, these two rays are the coming when we are making it backward. It's a virtual, not real. Okay, next we will see the table in which nature, position and relative size of the image formed by convex lens for various portions of the object. Let's see the table. First one, position. First heading is what? Position of the object. Then what? Position of the image, relative size of the image, nature of the image. First we have seen when the object is at infinity, where the image position at focus f2. What about the size of the image? Highly diminished, point sized. So where we have seen that? Yeah, this is the case. Object at infinity. What kind of an image? Image is formed at the second focal point. Point sized. That means highly diminished. Since it is convex lens, real and inverted, point sized, highly diminished. Real and inverted. Next is beyond 2f1, where image is formed between f2 and 2f2. What is the size of the image? Diminished, real and inverted. See, beyond 2f1. So, where image is formed between f2 and 2f2. Object is beyond 2f2. Object is beyond 2f1, where image is formed between f2 and 2f2, diminished, real and inverted. Then at 2f1. Then image is also at 2f2, same size, real and inverted. At 2f1, image is what? At 2f2, same size, real and inverted. Same size, image is of same size, real and inverted. What will be the magnification? Magnification 1. That is no magnification because object size is equal to image size. Then third case, between f1 and 2f1. Once again, between f1 and 2f1. Between f1 and 2f1. So where image is formed beyond 2f2, real, inverted, enlarged. Enlarged and magnified both are same. Enlarged and magnified both are same. Okay. Then at focus f1. At focus f1, where image is formed real and inverted, magnified, image is at infinity. Image is at infinity. Image at infinity, infinitely larger, highly enlarged, real and inverted. Then the special case between f1 and optical center on the same side of the lens as the object. Very important case, special case. Enlarged, virtual and direct. So convex lens forms virtual and direct image only in one case, where when the object is between focus f1 and optical center O. When the object is between focus f1 and optical center O. Next, image formation by concave lens. See, concave lens. It appears to diverge away from principal focus if the incident ray is parallel to principal axis. Again, I am telling, if the incident ray is parallel to principal axis, it appears to diverge away from the principal focus f1. Now, second case, when the light ray is falling at an angle at a concave lens, it after refraction what it is raised, it goes parallel to principal axis. It goes parallel to principal axis. Then through the optical center, it goes undeviated because it is falling through the normal. See, there are only two cases. Same as what? Convex mirror. Here it is similar to concave lens. Convex mirror working almost similar to concave lens working. Okay. So two rays are coming. So after refraction, they deviates away from the concave lens. So if you project it backward, we can see that it appears to diverge away from the principal focus. The same thing happens here. What happens? See, one ray is falling here and the other ray is falling through the optical center. So what happens? When you project the first ray backward, these rays intersect here. So you can see the image there. What about the image? Here, first case, it is a point sized image. Here, object is at infinity. Object is at infinity. Object is at infinity, where image is formed principal focus. What about the size of the image? Point sized, highly diminished, virtual and direct. Point size and highly diminished. And here what happens? Object is between 2f1 and f1. What about the image size? Diminished. Diminished and erect. Diminished and erect. See, at infinity at focus f1, highly diminished, point size, virtual and erect. Means it is, I am teaching you concave lens, which is similar to what? Convex mirror. So it forms what? Virtual and erect. Between infinity, first case infinity, image is formed at f1, virtual, erect, highly diminished. Second case what? Object is between 2f1 and f1. What about the image? Virtual and erect, diminished. Image is formed in second case. Image is formed between f1 and optical center O, diminished, virtual and erect. So concave lens always forms virtual, erect and diminished image regardless of object position. Concave lens always forms virtual, erect, diminished images regardless of object position. Can we say the same line in terms of in the case of convex lens? No, convex lens generally forms real and inverted, But in a special case, it forms virtual and direct. One special case that we have seen. Next, length formula 1 by V minus 1 by U equal to 1 by F. Magnification V by U. Remember, magnification mirror minus V by U. Magnification in lens V by U. Always remember, magnification lens V by U plus V by U. Magnification mirror minus V by U. Sign convention for lenses. All distances measured from optical center. Distances measured along the direction of light positive. Distances measured opposite to the direction of light negative. Height measured upward positive. Height measured downward are negative. Which are very much similar to sign convention mirrors. So, sign convention lenses and mirrors both are same. Power of a lens, very important question. Reciprocal of focal length is called power of a lens. What is power of a lens? Reciprocal of focal length is called power of a lens. Unit diopter, very important. Power of a lens unit is diopter. Remember, power of convex lens is positive. Why? Convex lens focal length is positive. Power of concave lens is negative. Why? Focal length of concave negative. Focal length of convex lens positive. So, what is power 1 by F? If F is positive, power is positive in the case of convex lens. What is power of a lens? Concave lens. Concave lens, what happens? Focal length is negative. So, power also negative. Concave lens. Combination of lens. When lenses are combined, total power is equal to sum of individual powers. When lenses are combined, total power is equal to sum of individual powers. Do remember that, sum of individual powers. For a combination lenses P1 plus P2 plus P3 etc. Power of concave lens is what? Negative. Focal length of concave is negative. Application. Concave mirrors are used in torches, searchlight, vehicle headlight. Used as shaving mirror. When the object is my face, when I keep concave mirror close to my face, I can see an erect image, magnified. So I have to be careful while shaving because I am having small pimples on my face. So I have to be careful. What mirror I should use? Concave mirror. Used in solar furnace. Used by dentists to see enlarged image. Generally, if you are having like a cavity in your teeth, dentist has to check that. So what kind of a mirror is used by dentists? Concave mirror. Solar furnace, concave mirror. Shaving mirror, concave mirror. Torch, searchlight, vehicle headlight. Train engine have two lights. For that lighting purpose, we have to focus the light into the railway track. So we use what? Concave mirror. Convex mirror used as rear view mirror in automobiles, giving why large field view always forms erect image, erect virtual image. Always gives erect image. That is the reason why we are using convex mirrors in automobiles. Lenses. Convex lens used in magnifying glass, camera, microscope. Concave lenses are used to correct myopia. Myopia means short sight or nearsightedness. What is nearsightedness? You can see nearby object but can't see far away object. Then that problem of the eye is called myopia or short sight or nearsightedness. Convex lens used to correct hypermetropia and presbyopia or far-sightedness. Or long sight. That means what? Long distance you can see, but you can't see nearby object. If you are able to see nearby object but can't see long distance object, it is called nearsightedness, short-sightedness, myopia. But if you can see far away object but can't see nearby object, it is called long-sightedness, hypermetropia or far-sightedness. And also presbyopia, we use convex lens. Just simply by heart that.